9, suppose the angle theta is in quadrant 2 and sine theta equals 2/3. Find the values of the 5 remaining trig functions. So how are we going to do this one? This is similar to some we did earlier, but we have to remember that all silver teacups. So I'm in quadrant 2. And this is definitely going to take a lot of practice. But I'm in quadrant 2, so that means I'm over here somewhere. And what do we remember about quadrant 2? Well, all silver teacups. This is the S one, which means that sine and cosecant are positive and all the others are negative. So we got to keep that in mind. The rest of it we can do like we did previously. We know that sine theta is equal to 2/3. And of course we know that sine is defined to be y over r. So we've got y equals 2, r equals 3. We can find x if we use our Pythagorean theorem. So we can do r equals the square root. So this is like the examples we were doing in the beginning of this section. R equals x squared plus y squared. And so we're going to substitute 3 equals the square root of x squared plus 2 squared. So we can square both sides. We'll get 9 equals x squared plus 4. Subtract 4 on both sides and we get 5 equals x squared. And then to solve for x, take the square root. Remember, when you do your square root property, you're going to do plus or minus the square root of your constant. So plus or minus the square root of 5 equals x, but we got to think a little bit more to determine which sign we need to use. So does x need to be positive or negative here? Well, y is positive, and we know that sine is positive, so I'm gonna just say x equals square root 5. And we'll figure out our sine in a minute. So we've got x equals square root 5. So we can go through and do all of our sine functions. So we've got sine theta. We're asked to find, so we know sine theta was 2/3. We're going to find cosine theta. Cosine theta is going to be x over r. And we got square root 5 over r, which is r's 3. Should this be positive or negative? Because I'm in quadrant 2, only sine and cosecant are positive. So cosine has to be negative. Tan theta. Same thing with tangent. Because we're in quadrant 2, only sine and cosecant are positive. That means tangent will be negative. So we're going to have y over x. So 2 over square root 5. So basically that means we needed to choose the negative one over here. And then to get the other 3, we know how to do that. Cosecant is the reciprocal of 2/3, so that's 3/2. So you don't have to worry about thinking about the signs when you do your reciprocals. It's just going to be the same as you had over here. So cosecant is the reciprocal of sine. They're both positive. Secant is the reciprocal of cosine. They're going to have the same signs, so negative 3 over square root 5. I do have to rationalize my denominator though. So multiply square root 5 over square root 5, and that's going to give me negative 3 square root 5 over 5 for secant. Cotangent, I do the reciprocal, and I keep the same sign, so that's going to be negative square root 5 over 2. And that's it. So those were the remaining 5 trig functions. So how did we get all this again? Most of it we did just like we did the problems earlier in the section. We used our formula to find our radius. This is like the very first 2 examples we did in this section, but we also had to remember all silver teacups to get the appropriate signs for them. Okay, so my answers were sine was 2/3, cosine was negative square root 5 over 3, tangent was negative, I didn't rationalize that denominator. I'm sorry, I forgot to do that. So tangent should have been negative 2 square root 5 over 5. Okay, so let me say them one more time. Sine was 2/3, cosine negative square root 5 over 3, Tangent was negative 2 square root 5 over 5. Cosecant is 3/2. Secant is negative 3 square root 5 over 5. Cotangent is negative square root 5 over 2. Next, we're ready to discuss the Pythagorean identities. As you can see, I've marked these as extremely important as well. Before I just give you those formulas, I want to show you how we get these. Let's start with the Pythagorean theorem. So with what we've been working with, we've been doing x squared plus y squared equals r squared. Let's just play around with this. Let's see what would happen if I divided both sides of this by, let's say, r squared. If I divide both sides of this by r squared, I've got x squared over r squared plus y squared over r squared equals r squared over r squared. All right, let's see if we can simplify what we have. R squared over r squared, that's 1. That's easy. What about these? We've got x over r quantity square, and then the second term could be written as y over r quantity square. Okay, but in terms of trigonometry, we have another name that we can give x over r. Hopefully you remember x over r is the same thing as cosine. So you can say that this is cosine square, you can say that this is cosine of theta quantity squared. Now cosine theta quantity square, we're actually going to write it as cosine square theta, like this. It's important to put the exponent with the function and not with the theta, because that has a different meaning. What is y over r? Remember, y over r is sine. So y over r quantity square is going to be sine square theta equals 1. This is one of your Pythagorean identities that you have to know. So anytime you've got cosine square plus sine square, that always will equal 1. That's super important. Make sure you know it. I'll do one more and then I'll just give you the last one to remember, to memorize. So let's do x squared plus y squared equals r squared. That's my Pythagorean theorem. And what if I divided everything by x squared this time? Let's see what happens now. So divide each term by x squared. Okay, well x squared over x squared, that's 1. And this is y over x quantity square equals r over x quantity square. It's a fun little exercise to see if you remember what these are. What is y over x? I remember that one using ticks. So y over x is tangent, T-Y-X. 1 plus tan square theta. R over x, you might not remember that one as easily, but you should remember x over r. X over r was cosine. So what is r over x? Well, that's the reciprocal of cosine, which is secant. So this is secant square theta. So we have another identity that 1 plus tan square theta equals secant square theta. Okay, and that's my second one here. Tan square theta plus 1 equals secant square theta. And then the third one, you would get this one if you divided the Pythagorean theorem by y squared. You would get 1 plus cotangent square equals cosecant square theta. So, you have to know these. This is another thing to add to your list of things that have to be memorized, and you're just going to have to do it however it works for you. This is the first time I've taught this course, and I'm not, it's been a really long time since I've done trigonometry, so I've had to do the same memorization that you're having to do. So, whatever it takes to help you remember it. It might help you here with the cotangent and cosecant. You've got 1 plus co equals co. That might help you remember that one. I don't know. You'll just have to, whatever works for you, but you'll have to make sure that you know these Pythagorean identities. And we're getting ready to use these, I think, in the next example. Okay, we've also got quotient identities. These have to be memorized also, but they're not, to me, they're easier. I can't really say why they are, but I know that, since I know that tangent equals y over x, I associate sine with y, I associate cosine with x, so that one to me is not as hard to remember. But it's true that sine theta divided by cosine theta equals tan theta. Also, cosine theta over sine theta equals cotangent theta. This is just the reciprocal of the tangent over here, so you just flip it over. So we're going to do a couple of examples that involve using these identities. In example 10, find sine theta and tan theta given that cosine theta equals negative square root 3 over 4 and sine theta is positive. So, going back, look at the Pythagorean identities that we just talked about and look at the quotient identities and see if you can find one that might be useful for this problem. So what are we given? We're given the cosine value. Since I'm given cosine, and I have to find sine and tangent, be careful. When I first did this, I tried to use one of these, but there was a problem with the range, so it didn't work. So if you try to use this one, be super careful that it fits, that you're not violating the range of whatever function you're working with. But if we come up here to this one, we've got this Pythagorean identity that involves cosine square. This is a good place to start. I could put my value, my negative square root 3 over 4 here for cosine. So we're going to do sine square theta plus cosine square theta equals 1. So I've got sine square theta plus, I'm going to use parentheses because this is a negative. Alright, cosine is negative square root 3 over 4, and I need to square this and set it equal to 1. Oh, I'm sorry, I didn't realize I was off the screen like that. Yeah, that's what I'm doing. Now, we're going to solve this for theta, or we're solving this for sine theta. So this gives me sine square theta plus, alright, this is going to give me square the square root. I get 3 over 16, and of course I'm squaring a negative, so that makes it positive, equal 1. Subtract 3/16. So sine square theta equals 1 minus 3/16. So you can do that on your calculator if you need to, but it's really not hard because you're doing 16/16 minus 3/16. Gives you 13/16. Take the square root of both sides, and you get sine theta equals plus or minus square root of 13/16, or plus or minus square root 13 over 4. Okay, now how do I know whether to do plus or minus, or which one to choose? They told us up here that sine has to be positive, so that means we're going to choose the positive answer. Square root 13 over 4 is sine theta. And then how can I get, well, that's it. That's all I had to, oh, I'm sorry, I have to find tangent. So to get tangent, maybe we go back to the reciprocal identity, or yeah, let's look at those Pythagorean identities again. Is there, you think there's either way I can get tangent? Well, this formula has tangent. And it's got secant. Can I get secant? Yeah, because secant is the reciprocal of cosine. And I've got cosine. So I can do this one. So I'm going to use this second Pythagorean identity to help me get tangent. Looks like I might need another sheet of paper. Alright, so what do I have so far? I know that cosine theta is negative square root 3 over 4. And I know that sine theta is square root 13 over 4. I need to find the tangent of theta. And I'm going to use this identity. So I have tan square theta plus 1 equals secant square theta. Alright, so tan square theta plus 1 equals, secant square is going to be 1 over cosine square. So that's going to give me tan square theta. You don't have to put, you may not need as many steps as I'm putting in here for this, but I'm just trying to make sure that I don't skip anything. So tan square theta plus 1 equals 1 over, and cosine square would be, what is it? You can write it that way if you want to at first. Negative square root 3 over 4 quantity square, which equals 1 times the reciprocal of that. So you could do 4 over negative square root 3 quantity square which is 16 over, we're going to square that negative, so it's going to make it positive, and then you've got a 3, so 16 thirds. Alright, so I've got tan square theta plus 1 equals 16 thirds. I can subtract 1 on both sides. So tan square theta equals 16 thirds, and if I subtract 1, I'm going to subtract 3 thirds. So that gives me 13 thirds. Alright, then I have to take the square root to get tangent, because this is tan square, so tan theta equals plus or minus the square root of 13 thirds. I do have to rationalize, so that's going to be plus or minus the square root of 13 over the square root of 3, plus or minus, do square root 3 over square root 3, that's going to be square root 39 over 3. Now, so we got tan theta equals plus or minus the square root of 39 over 3. Which one of these do we choose? What sign should it be? Is it positive or negative? Go back to the original problem. Let's see if we can decide. We were told that sine is positive, and we know that, okay, so we know that sine is positive. We know cosine is negative, sorry. Sine is positive, cosine is negative, okay? And since we know that tangent is sine over cosine, if they're opposite signs, that would make tangent negative. So tangent has to be negative. So our answer for tangent is going to be negative square root 39 over 3. Okay, negative square root 39 over 3. And we already had cosine, negative square root 3 over 4. And there are, you may do it a different way. You don't necessarily have to do it exactly the same steps that I'm doing. That's one thing about trigonometry that's going to be, maybe, it might make it seem harder than it really is, because just because I'm doing a problem a certain way doesn't mean that the way you're thinking about it is necessarily wrong. There are many, many different ways to do problems like this. That was what I got there. Negative square root 39 over 3 for tangent. We are almost done with this. I think I've got 1 or 2 left. Alright. So in my notes, even though I know I went on to the second page, I'm just going to put in, we had that sine theta was the square root of 13 fourths. And, oh, is that the right one? Yeah. And then we found that tan theta, I'm just going to write the answer here. Tan theta was negative square root 39 over 3. So that's what I would expect to see in your notes. There. Oh, I think this is the last one. Yep, I think that's the very last one we have to do. So example 11, using identities to find function values. Okay, so same idea. Find sine and cosine given that tan is 4 thirds and our angle theta is in quadrant 3. So let's start by thinking about the signs. If I'm in quadrant 3, that puts me down here. So all silver tea cups. If my angle is in quadrant 3, then tangent and cotangent are going to be positive, all others negative. So we can use this if we're trying to figure out what sign we need to have as we're going through these. So only the tangent and cotangent will be positive in this problem. We have to find sine and cosine, okay? So how are we going to get that? We know that tangent is, there's different ways that you can go about this. They're asking us to use the identities to do it, so I'm going to try to do that, but you could do it other ways. If I look at my identities, I believe this is the one. This is the one where you could easily screw up, because if you go to the quotient identity, it looks like it would be really easy to solve it using the quotient identity. But if you do that, you've got an issue with it violates your range. If you tried to say that 4/3 is equal to sine theta over cosine theta, 4 is not in the range of sine, and 3 is not in the range of cosine, so that one's not going to work. So this is not going to work here, even though it looks like it would have been really nice if it had. So let's go to the Pythagorean identities and see if that will help us. Alright, so we were given the tangent. So I'm going to go to the Pythagorean identity that has the tangent, and I think that's going to get me what I need. So I'm just going to put 4/3 here. So I'm going to use the tan square theta plus 1 equals secant square theta. So 4/3 square plus 1 equals secant square theta. We used this one in the previous example too. So I'm going to solve this for secant. So that's going to give me 16/9. You can write 1 as 9/9. Add those, you get 25/9. And then to get secant theta, I take the square root of both sides. You would do plus or minus the square root of 25/9 equals secant theta. So you get plus or minus 5/3. Okay, now what is secant? Remember, secant is the reciprocal of cosine. So you've got plus or minus 5/3 equals 1 over cosine theta. Okay, you can also think of it as just taking the, you know what, I'm not even going to, you can write it that way, that's what the rule says, but it also means that cosine is just the reciprocal of this. So that means that plus or minus 3/5 equals cosine theta. Well, which one do we want? Do we want the positive or the negative? Well, we look up here. We know that tangent is going to be positive. Everything else, tangent and cotangent are positive. Everything else is negative. So that means we need to choose the negative value. So negative 3/5 for cosine. All right, and what else do I need? I've got to find sine. I need to find sine theta. So I'm going to see if I can squeeze it in over here. What can I do to get sine theta? Since I have currently cosine and tangent, when I need to get sine, I would go to the sine square plus cosine square equal 1. That's going to get it for me. That's all I need. Since I have cosine, I can put negative 3/5 in here for cosine. So, I'm going to go back up here now to finish it out. So I'm going to do sine square theta plus cosine square theta equals 1. So sine square theta plus negative 3/5 quantity square equals 1. Sine square theta plus 9/25 equals 1. Sine square theta equals, that would be 25/25 minus 9/25. 25 minus 9, that would be 16/25. Take the square root of both sides. Sine theta equals plus or minus the square root of 16 over 25, which is plus or minus 4/5. And what do we determine about the sign of the sine function? Is it going to be positive or negative? Okay, we just looked at this. We know that because my angle is in quadrant 3, only tangent and cotangent are positive. So that means sine has to be negative. So sine theta, it would be negative 4/5. So we found sine theta was negative 4/5, cosine theta was negative 3/5, and we are done. And again, this problem certainly could have been solved another way, but we were asked to use the identity, so that was the reason that we chose for going that route. But this is what we got for our answer. And this is the end of section 5.2. So we've done a lot here. Key points that you've got to make sure you've got. The all silver teacups, you have to make sure you understand how to determine which quadrant has which sign, or which which trig functions have which signs based on their quadrants. And you've got to know the definitions of sine, cosine, tangent, and the reciprocals, cosecant and secant and cotangent. But that's it for this section. Also, you need to be working on your unit circle. Be thinking about how to memorize, especially this first quadrant up here. This is absolutely crucial. You've got to know this stuff up here, and we're going to be working on that as we go. We're going to be talking more about the unit circle in section 5.3. So thank you for bearing with me this long, and good luck with this. We'll be working on this in class.